Assalamu alaikum students. In the subject of physics class 11th unit laws of motion, today we are going to discuss Newton's third law of motion. Before moving to the topic, let us have an interesting discussion. Do you know there are the people who remain in the space thousands of kilometers above the ground, thousands of kilometers above the ground into the space. They remain there for weeks, even they remain there for months together. Okay, then they come back from there. Next thing, there is a race of missile race, rocket race, the race of war plans in the world. What is the thing which provides them the success in creating such things? It is third law of motion. Okay, not only this third law of motion is not only valid in the space, it is valid everywhere in the universe, everywhere in the earth. Okay, it can be seen, observed in our day-to-day life, in our domestic life, right? It is because of the fact that we call these laws of motion as universal laws of motion, because they are applicable for every sort of forces. So this third law of motion, it is an interesting law, it is an interesting fact which we should know, right? So let us move to the topic of this Newton's third law of motion. Let me add some other inquiries to your knowledge. See, we cannot walk upon the water. We are not able to walk upon the water. Helicopters, they cannot fly on very large heights. In the same way, see, this is a freely falling body, pen. It comes down, meaning it is attracted by a force given by this earth. Do you know there is also the same amount of the force, same force which is by which this pen attracts earth? Means if we are observing the attraction of this pen, it is coming towards the earth as earth attracts this. But there's a fact that the pen also attracts this earth, whole earth, by the same force. But we cannot observe the attraction of the pen which applies upon this earth. So the answers of these all things you can get from this Newton's third law of motion. Okay. So before moving to the statement of this third law, let us understand a few facts. First one, forces always arise in pairs. This is an important point to know. Force never remain a single. Okay, forces always arise in pairs, right? See, if this is a body A, it strikes to body B, so this is force. Then we know that there is the force which will be reacted by the body B, right? So there is a reactive force provided by body B. Okay, so there is action and reaction. If I collide with the wall, so my force applied upon the wall is action, then the wall will react it back. Okay, if a bird, it flies in the space, in the air, it applies the force by his wings. So this is one force. Then the reactive force is the force which is provided by the atmosphere to their wings. Okay, again there are two forces, action and reaction. Force given by the wings of that bird, then the reactive force provided back by that atmosphere, which then helps him in moving forward. If a person is swimming in the water, he applies a backward force upon the water, then the water reacts back with the force which helps him to move forward. So it is the thing which you should know, that force always arises in pairs. Okay, force always arise in pairs. If one force is called as active for action force, then the next force at the same time, and this thing must be kept in mind that both the forces develop or arise at the same instant. Whenever there is action, at the same time there is a reaction. Okay, so if this thing I call as action, this will be reaction, but I can reverse it. If this is action, then this will be reaction, because both the force, action and reaction force, they arise at the same instant of the time. It is not that when we first act, then there will be a reaction, though. No, this is the confusion which we should bring out of our mind, that first action then reaction. No, both the things, both the action and reaction, they arise at the same time. Now let us have the statement of this Newton's third law. If you got understood what is action, then what is reaction, if you got the understanding of the fact that the force never arises as a single one, it arises always as the pair of force. There is a forces always in the pairs. One force if we call as action, then the next one will be called as reaction. So how we can state then this third law of motion? Let us have the statement. This is a statement of third law of motion. To every action there is an equal and opposite reaction. So if there will be action, the same force is reacted back by the next body. Okay, so if there is 10 newtons of force in action, in the same way there will be the reactive 10 newtons of force, but in opposite direction. So there is equal force. This force and this force, they will be in the same magnitude but in opposite direction. If one force acts in positive direction, then the reactive force, it will always be in the opposite direction. If this is an example, if F of A, B is a force by body A upon body B, then the reactive force back by the body B upon body A, if it is denoted by FBA, then these two forces are equal but opposite. This is positive and this is negative. Okay, so let us illustrate another some things upon by this third law of motion. First one, it is clear that forces occur in pairs. Okay, now the next one, action and reaction involve a pair of bodies. There will be always a pair of bodies where there will arise action and reaction. Okay, so these are the examples of third law of motion. Walking. In the walking, what happens? Our foot, they act upon the earth in the backward direction, and then the earth reacts us in forward direction. Then we can walk. In the same way, swimming, the swimmer, it pushes back backwards the water reacts in forward direction, helping him in moving forward. And same way, the rocket propulsion. In the rocket, what happens? See, if this is a rocket, okay, it ejects the exhaust from the nozzle behind the rocket. So there is action by these exhausted gases. When they act in backward direction, then there arises the reactive force due to this exhausted energy, which reacts back in the opposite direction, means in the forward direction of the rocket, as such rocket gets the help in moving forward. Let me repeat it. In the rocket, what happens? The exhausted gases come out of the nozzle behind the rocket in a very fast energy and motion. So this is action. Then in the reaction, this exhausted gas, it reacts back and pulls the rocket in the forward direction. As such, rocket proceeds in forward direction. Right? Same happens for the collision systems, action and reaction. So it is clear in third law of motion that there are always two forces, the active force and reactive forces. Both forces are in equal magnitude but in opposite direction. So this was all theoretical aspect of third law of motion. Let us discuss the mathematical approach of this third law of motion. See, let me have two bodies A and B in an isolated system. Isolated system means that system in which external force is zero. Meaning, if this is an suppose that this room is an isolated system, It is isolated only when there is no external force. Okay, when there is no external force, then the system is called as isolated system. For isolated system, external force is zero. Okay, so let these two bodies, they move in the straight line. Let two bodies A and B are in let two bodies A and B are in isolated system, moving in straight line. Let these two bodies, they move in a straight line and collide. After that, let they collide. After collision, let we have two bodies A and B. They are moving in a straight line. After collision, what will happen? There will be the change in momenta. If there was one value of the momenta in the bodies, now after collision, it is clear that the momenta will change. So now the new momenta, the change in momenta will be denoted by delta P1 for this body, delta P2 for this. Delta means the change, and P1, you know, it is a momenta. So for this new momenta is delta P1, and for this change in momenta is delta P2. And by law of conservation of linear momenta, we know that for an isolated system, the total change in momenta is zero. This thing you should know in that law of conservation of momenta. So the total change in momenta, this is change in momenta for first body A, this is change in momenta for next body, then the total change, delta denotes change in total momenta, it is equal to 0. Okay, so bring this here, it will be delta P1 is equal to plus, it comes here, it will be negative of the P2. Let me proceed. See, this is equation of first, which we got is delta P1 is equal to minus delta P2. Now divide both sides by delta T, and put the limit this tending to 0. Okay, so this delta gets converted into T when we apply limit delta T. When we apply limit delta T, this delta change, it gets converted into differential Tp point by Tp2. And by second law, you know that second law is that momenta is equal to the force, right? This is second law of motion. So if we apply this second law of motion in this, we get this change in momenta, this is change dp by dtt. Rate of change of linear momentum is directly proportional to applied force. This is second law of motion. So applying second law of motion, see, this is the moment of this body P1, and this P2 is the moment of this body. This is the moment of this, and moment of this is this. By second law, we know that this change in momentum is directly proportional to their force. So what is the force over here? That is force F of AB is equal to, here this momenta, since we know that momenta is directly proportional to force, so in this momenta the force is this, so we can write F of BA. Here it is negative sign, so we got it that F of AB is equal to minus of F of BA. So this is the derivation of second law of motion. Okay. Now I think that you would have got the answers of those very first questions, that how missiles they proceed, they move forward. It is clear that they eject gases in the reactive manner. Then those ejected gases in the active, the gases in the active manner are emitted by the rocket through the nozzle. Then in the reactive manner, the rocket proceeds forward. Okay, in the same way the jet aeroplanes work upon the same principle. In the jet that planes, they eject the gases from their nozzles. As such, those ejected gases, they provide them the reactive force in proceeding forward. Now the next point, why we cannot walk upon the water by these foot? It is easy, that simple, that if there will be action, then there will be the reaction. We are applying active force upon the earth, then earth provides us the reactive force which helps us in proceeding forward. On the water, what happens when we try to apply the force upon that water, these foot, they sink into the water, that we cannot apply more force, more active force upon the water. As such, we are not getting more reactive force which is required in proceeding forward. Now, if we bring a plain sheet and that attach with our feet, then if we try to move upon the water, that plain sheet, like that buoyant force, if you know the buoyant force, due to that buoyant force a sort of action can be applied upon the water surface, which can apply a little bit reactive force. As such, we can proceed, but for that we should have a very flat these sheeters which apply active force due to the buoyant force phenomena. As such, we can proceed forward. When we use these feet, and these feeters get sink into the water. As such, we are not in the condition to apply the force of actions, for which we should get reactive force in proceeding forward. So this was all regarding your third law of motion. Now this third law of motion can be calculated from second law of motion. By that very beauty, we call the second law of motion as real law of motion, because from second law of motion we can derive first law as well as this third law. So thank you. Have a nice day. Assalamu alaikum.